What's up, gangsters? How about episode 2 of this 3D printing adventure? I think with this episode, what I want to do is just kind of look at some of these parts that I've been printing as I go along to kind of figure out how to use my new epax x1-4k. Also to kind of evaluate the epax hard black resin that they sent me with the machine. You know, just kind of see how the surface finish and resolution is working on other parts that are a little bit different than the little town file test part. Also, kind of cover a little bit on removing supports, assembly, finishing, just kind of a variety of things. So hopefully this will be a useful episode. Okay, so since I filmed the last episode, first episode of the adventure, what I've been working on is all this stuff. After I printed the little town part from Amerilabs, felt pretty good about those results. Of course, it was time to actually print something for real. They call them test parts for a reason. You know, they're supposed to be easy. That one is easy. I mean, it's challenging, I guess, for the machine in terms of resolution, but it is easy for the user because it's got no supports. You just load the thing up in your slicer and print it, and off to the races you go. But when you start printing your own stuff, now you have to start doing things like figuring out supports. And so this is now my first time to really get into that, because that's one of the benefits of getting somebody else to do all your printing for you. They have to figure out the supports, but now it's on me. So I thought, well, why not start out with the seat from a project that I recently finished, and that is sitting right over here. Just happens to be here still on my bench, but a little dusty. Anyway, it's this P40 Warhawk, and that is the seat, which I designed in Fusion 360 and had my good buddy, who's a very good printer, print for me. And it's a good test. I purposefully designed it to kind of push the limits of his new, at the time, Frozen Sonic Mini, which is a 4K machine. And so it's got pretty thin walls. I think the overall shell thickness of this thing, because it's supposed to mimic, the real thing being made out of sheet aluminum. So the shell thickness there, the basic shell thickness, I think is 0.2 or 0.3 millimeters, pretty small. And it's got some features on it, like there's some rivets up here on the back of the seat that maybe you can see that get down around Anyway, as I was saying before my card ran out of space, is you can see that there's some really fine detail on these parts. The back of the seat, hopefully you can see those, has got some rivets there, and those are down around 0.15 millimeters in diameter and depth. So that's really pushing it for just about any machine. The part that's actually in the model that I showed you was printed on a Form 3, which is about a $3,500 machine, and it's laser driven as opposed to being a masking LCD type printer. But anyway, so these, so what lessons did I learn here? What happened here? So this is the first set, and you can see I ran auto supports and just let it do its thing. I set the orientation up myself because I kind of have a good feel for that. But you can see these parts, they're finally, these have been printed now for about 4 days. They're finally starting to harden up. Why? But you can see still a bit rubbery. Why? And why are they so warped? Yeah, well, because my first lesson I learned, I don't know why I did this. I put these in the wash and cure station for 15 minutes. yeah, I was like, oh, we'll just really get all that unprinted resin off of those things. Well, and I also left them stuck to the build plate. I just had it suspended upside down in the washing cure. And so between the tidal forces and the isopropyl alcohol, which is a solvent for uncured resin, being in there for so long, these things did turn into rubber, and they're still not solid, and they were warped as fuck when I took them out. So, and you can see where like the supports like just tore away from them. So yeah, 15 minutes, way too long. So printed another batch. In fact, I'm just going to go ahead and put those in the round file. Printed another batch, and everything the same except for I only put these in the washing cure for 3 minutes, and much better. But I still had the same failure. These supports under here just completely got blown away, totally failed. Don't even really understand why. And it's the same set of supports on both of them, and you can see that some of the material ended up poking out of the front there. So yeah, that wasn't good. The other thing that happened, one of the seats, all the supports were great, but the seat was completely gone, not even there. And it was a smudge on the FEP. So yeah, I had to dump all the resin out, clean all that off, which was no big deal. But one thing I also noticed here was that even though everything else was pretty okay, that there was a little bit of warpage. You can see on the bottom of that seat, it's not quite flat. And then you can see on like the back of this one, you can see really well right there where it kind of looks like it's bubbled up. Yeah, that's warpage, not good at all. So I figured that maybe what caused that, because that was there prior to putting it in the washing cure. So I felt like maybe my layer time was not quite long enough. So I just kicked it up just a tiny bit, 5%. I went from 2 seconds to 2.1, which I'm told is kind of pushing it on a mono screen. But yeah, it seemed to work fine, because assuming that was the issue, these parts do not have that same sort of warpage. But that's what happened. That right there is what happens when you get a little hair floating. I guess that's what that is, what it looks like in the resin. Anyway, but what was interesting is I changed the supports on these. I did auto supports, and then I went back and I deleted a whole bunch of them. I also upgraded to the Pro version of Lychee, so now I can modify my own supports with a lot more freedom. And you can see, I completely changed it. I went from, I increased the diameter of the supports, just made them a little stronger, got rid of all the braces just to see what that would do. And this one, since it ended up having almost none of the supports left, again, and I don't understand why, maybe at this orientation, I really don't even need any supports for the back of the seat. That was kind of my instinct, but I thought I should put some. But another little thing, with auto supports, and a lot of people don't like auto supports. I guess I'll decide, but you have to be careful where it puts it, because like you can see here on the back of the seat, there's a little rectangular indentation over there on the left side, and it stuck a support right in the middle of that, and that material is really thin right there, and so that's dangerous when you're getting that support off of there. So it's just it's just a matter of paying attention and then being able to edit the supports the way you need. So. But anyway, I'm stoked, because the bottom line is this is I think a pretty challenging thing to print, and these came out really good. I'm going to shoot some primer on them because they always look the best that way. But you can see that the inside faces of the seat look pretty smooth, pretty nice, which is really the most important thing. That's the visible face. The left side looks pretty good, but then when you flip it over and look at the right-hand side, you can see all those build layer lines, and that's just the thing, with printing these parts. there is no ideal orientation. And so I maintain that anybody who tells you always put at an angle, or even worse, starts telling you to always put at certain angles, they just really don't have any idea what they're talking about, because every part is different. And especially when you get into hard surface mechanical parts like this that have flat faces, yeah, those angles go out the window. And what's kind of ironic is that a lot of the people who will spew these rules about angles at you are people who print nothing but figures, Warhammer minis or busts or whatever. And truly, angles don't, I mean, the specific angle on parts like that don't really matter, because the wrinkles in the soft surfaces pretty much hide most of the issues that the angles are supposed to help you with. So the angle, really, honestly, the main benefit that I feel like the angle gives you is it reduces your build time, because you have less vertical height. So anyway, that's kind of that on those parts. But I also have some parts here that kind of get into another subject. My same guy who printed the seats originally also printed all of this stuff. Now these are basically test shots from a kit design project that I've been involved in. These are parts of the soon to be released, it's mid-September now, hopefully by November, soon to be released by Fantastic Plastic. This is the 1/44th scale MCRN Morrigan class destroyer from the Expanse. If you guys have, if you're sci-fi nerds, maybe you've read the books, they're really good. It's got 5 seasons of the show on Amazon, and this is one of the ships, one of the less known ships. But anyway, pretty cool. And so this was my first project for the guys, Guy, because it's really a one-man show over at Fantastic Plastic, to do the kit design. And he is printing his own parts, and those are most of them are gonna be turned into master patterns for resin casting for the kits. Really low volume stuff, really the definition of garage kit type thing. But I wanted to, see how my engineering was, see how the thing went together, and just, build one and have a little fun with it. Just build it and paint it, nothing crazy. And so I've been working on it, and I'm into test fitting and finishing. And a couple of things that come out in this, because there are people who talk about injection molding being replaced by 3D printing, and that is just silliness. And here's why. These are really well printed parts, but you still have surface finish issues, like I was pointing out with the seats a second ago. Okay, this piece right here looks really good. I mean, that is a nice surface finish. And it's pretty good, looks pretty good on all sides. So that's nice. But when you take a look, let's take a look, here's one. Okay, so this part was built, I don't know what the exact orientation was. I think it was maybe something like that, only on one axis. But all of these surfaces are supposed to just be flat, and you've got build layer lines. And where it's really problematic is like down in here in between these features of this door. Not a lot of room to get in there with sandpaper. Same kind of thing here on this whole subassembly. This is the front hull, and it was built, this is a top piece, a bottom piece, a front piece, and then these scoops are all 3 separate pieces. And so this bottom piece was built at an orientation, I think, kind of like that. It was upside down. It's hollow inside. And we wanted to put all the supports in there. And so you can see you've got, a lot of layer lines. And this has a heavy coat of Mr. Surfacer 1500 on it. And I've been sanding the shit out of it with my little Proxxon pin sander. This thing is the bomb. Hand sanding this, that's just a no-go for me. This little thing here, if I turn it on, if I can find the foot feed, there it is. I've got a foot pedal under my desk that turns it on. It's just a foot switch. But yeah, this thing is great. This is a bit of 400 grit Infinity sanding sponge that I've got stuck to the little foot here with 3M double-sided tape. And you can use it wet or dry, but I'm using it dry right now, and it's just phenomenal. I mean, look, you'll see here how fast this thing gets it done. So, okay, let's pick a spot just to demonstrate. So you can see here where I've sanded areas that are going to show. This area back here is not. But I can feel those layer lines with my nail, and just like that, pretty much done. I mean, that's, I'm using the primer as a guide coat for the first pass, so I can start to tell when I've sanded it flush, because obviously once I start exposing all of the ridges on the top of each one of those layer edges, and then start to get into the primer that's down in the low spots, then I know that the overall surface should be pretty flush. We'll see when I start putting some more primer on there, but that's the deal. Just, so quick and easy. So that's that for this little segment. And yeah, not sure what I'm going to come back with next, but yeah, we'll see. Okay, I think I'm going to wrap this up with another look at some of these parts that I've been sanding on, and these little seat parts, because I shot some more primer, and really primer is what it takes to really see the quality of a 3D printed part. It's just so hard to see when it's just in resin. So this is what that seat looks like with a little bit of Mr. Surfacer 1500 on it, and you can really see it is pretty good. Somebody mentioned something about running anti-aliasing. I'm honestly not sure where I'm at with that. I've got it set on standard level 8 in Lychee, and I haven't even really started experimenting with that yet. For any of you guys who don't know what anti-aliasing does, what you kind of have to imagine is that when you mask off a cross-section using an LCD, you're basically generating pixels, just like on any sort of video screen or LCD, LED type screen. And so, you're approximating curves with little squares, just like on this cutting mat. And what anti-aliasing does is it kind of juggles the position of the pixels so that the outlines of them are not so sharp. They kind of blur, and you get a sort of a grayscale. Like, imagine that these squares here are white, and these squares over here are black, and the light, the UV curing light, passes through the white ones and cures the resin and is blocked by the black ones. Well, what you do is you kind of make this go a little gray, and it softens the jagged edge right there. That's what anti-aliasing does. It can also sort of work in the Z direction, but that's a little bit different. Anyway, it can help eliminate some of the artifacts, not all. And obviously, the more of that you do, the more chance you have that your really delicate little details that require high resolution are also going to be softened. So when you've got things like those rivets in there, that's, anti-aliasing you may be working against yourself. But I'll experiment with that a little bit. Anyway, the seat looks really good with some primer on it. Let me show you this other part right here, because I specifically showed you one of these without primer, and you can see now with primer still looks pretty good. I mean, sometimes you have a part where the geometry just really lends itself, and you get the right angle. In this case, these were angled on two different directions, like 15 degrees in both X and Y. and those sides look really, really good. I mean, there's just, basically nothing there. But and it's good on the other side too, because you can see, it doesn't take a whole lot of geometry education to figure out that what may apply to one side might not apply to the other side or to a different surface. And that's exactly the case here, because as good as those are, look right down here on this, come on camera, focus up there. Look right down there on that lower surface. You can definitely see the build artifacts there. Layer lines. So again, this is why I go back to what I've been saying, that when you start trying to tell people, tilt your parts at 43.1 degrees. Yeah, that's just silly. That's all there is to it. All right, so you can see this part where I had done quite a bit of sanding, sprayed some primer on that, and you can see I'm getting there. But this is the process of priming and sanding. It's just good old-fashioned body work, and you just keep doing it until it looks good. That's it's just elbow grease and time. That's all there is for it. Now, I have also been continuing with my other test prints, and I've got a whole little batch of things here. This is super cool. These are from a guy on Patreon called Waladi's Studio. No idea if I'm pronouncing that right, but it pretty much spelled the way it sounds. Anyway, he's one of these guys that sells STL files that you can print yourself, which is a growing marketplace, especially with figures, minis, that kind of thing. And this guy, he designs some really beautiful stuff. And what this is, I actually got a picture of it on my phone, is a sculpt of this female robot thing where she is having this encounter with a butterfly, which I think is pretty cool. I like the juxtaposition of the high tech and the anthropomorphism and all that. So anyway, very cool design, and it was like $10 to be a Patreon member and download it. And eventually, I'm gonna build one of these and paint it for real. But right now, it's just for practice, and I'm just burning up some of this epax hard black resin. I'm gonna switch to the Anycubic Craftsman. Although, even though everybody seems to think that the Anycubic Craftsman is really, really good, both in terms of crispness and surface finish, I don't have a lot of complaints with this black stuff. I just, I got it for free with the printer, so I'm using it, and you can see that it is in fact pretty good. I mean, these are good prints, and this is also, again, is why figures just really lend themselves to 3D printing, because there's really no place where you can see any offensive build artifacts. And part of the reason too is because this guy's just done a really good job of designing it. He's got surface texture that he's designed into it in pretty much every area that works to disguise build artifacts. So it's just really good. And obviously you can't put surface texture on it like that with something like an aircraft seat. So yeah, this is why sometimes I just say, you just about can't go wrong with figures. Now her head is a little bit more of a mechanical thing, a little bit more hard surfaced, and you can start to see there's some places where you pick up some of the layer lines. But at 0.03 millimeter layer thickness, I mean, this is just, it's really pretty good. You can even see the knurling on the sort of lens thing that I guess is her eyeball. If the camera will focus, come on, there it is. I mean, that's just really, really impressive. Really impressive resolution and surface finish. Now, with the first batch of these, which was the head, the body, this gizmo right here, which also has really good detail. The print was almost completely successful. I didn't have any problems except, let's see where the arm is. There's a couple of really fine protrusions right there on the front of that I lost because they just were too small. And then I lost the thumb right here, which was annoying because everything else about it was really good, but I lost the thumb. And I don't think it was for lack of support, which, as you can see, I did pretty much auto supports on all of these. And you can see it generates a lot of cross braces, and that's great. You know, that's definitely more stable, although there really should not be any lateral forces. But, you know, it is what it is. I'm still experimenting. I'm using, I think, 0.3 millimeter contact points. For, you know, that's the point where the support contacts the actual part. Now, with this other batch, which was a reprint of the arm, and I changed the orientation, and it came out perfect. You can see there's the thumb. It's all good. It's all happy. I also completely changed the supports. What I did here is I just went in and I did a search for islands. Those are parts of a layer that are not attached to anything else, and that, you know, an unsupported island will definitely screw up your print. So what I did is I just told the software to find all the islands and add supports to all those, and then I went back and added some where I thought just instinctively I might need them. Like on the tip of the toe, right there, you can kind of see that underneath the bottom of the foot. I added some there, and this part also came out perfect. And you can see I don't have a lot of supports that I really have to deal with, so that's nice. I added some what you would call fan supports, actually on both batches, and that's where you're using what's called mini supports to create a little fan. These are probably a little too small because they got really wiggly right there, so I may need to thicken those up because they're probably not really doing much good. But this arm also came out really nice, and look at the detail on the butterfly wings, just absolutely phenomenal. I mean, that is so cool and so impressive. But yep, it was a 90% print because, yeah, this leg, the foot, was totes fail. Yep, lost the toes, the bottom of the foot, and the bottom part of the hip right there, I guess you'd call that. So gonna have to reprint that, but I'm probably not going to for this batch because I'm satisfied that I can print with this hard black. And what I want to do is I'm going to switch to the Anycubic Craftsman, and that's when I'll reprint all these. What I'm going to do with this is I'm going to take all the supports off of these and actually put this thing together so I can just kind of see, you know, how it goes together. Now, when it comes to removing supports, there's a couple of things you can do. I think everybody pretty much agrees that just breaking them off is a bad idea, especially with these hard resins, because if you do that, what'll end up happening, and you may see it on this one because I just broke them off here, is you'll get scars. All right, you can see right down there where the tips of the supports were, and they'll leave little divots. Now, it's not such a big deal on parts like this, but obviously on parts like this, you don't want to do that because, you know, you'll screw up your surface finish, or you'll have to come back and fill it and sand it later, which is a giant hassle. So what I typically use is a good set of nippers. These are single-bladed nippers that are really designed for styrene, but this set is kind of a spare set, and they're not quite as sharp. I don't really use them for any real delicate cuts that matter, and they do a good job. So you can obviously just go through and nip those off, no big deal. Now, there are situations where it's a good idea to nip, maybe a little further away and then come back and do a little sanding if you have to really get it cleaned up. Because again, even with nippers, you can leave a telltale. Now, if you have really, really delicate areas that you can't get to with nippers, my other favorite way to get rid of supports is power tools. Love power tools. So this is my Proxxon, and I've got a little abrasive cutoff disc on it, and these things are fantastic. I'll run it about 7,000 RPM, and I've got a foot switch under my workbench, so I can just kick it on. Oops, got my sanders plugged in too, and it's still turned on. Too many tools. So I just kick the foot switch, turn it on, get it going, and it's great. Now again, obviously you've got to be able to get into the area that you need to get into with the wheel, and that's not always going to work, but it works, in areas where you can. It's good because it will it'll buzz through the resin in a big hurry. Obviously it makes some dust. That's not always good, and sometimes, as you saw, because of the forces involved, it'll go ahead and pop the whole part off anyway. But it works pretty good, especially on parts like, let me grab something out of this box over here. These are some more of these parts for the Morrigan. So you got a lot of parts, you want to get through them quick, and these have relatively thick contact points, and I could really just clip all these off or break them all off and not worry about them, because we put the supports on assembly surfaces that don't really matter, or that won't be seen. But like this surface right here, that is a mating face right in here, and I want that to be flat, and I don't want to spend a whole lot of time doing cleanup. So the disc is good because it'll get in there. Let me get in close and just clean those off like that. You can also use like the little Dremel saw blade, and that works also really, really well and produces a really fine cut. But you may not enjoy having that thing, a little saw blade spinning at 5,000 RPM right next to your thumb. This thing, it's not gonna hurt you if you bump your finger into it, so it's a lot safer. The only thing I hate about these is that they're super brittle, and they break if you look at them funny, and they're a total hassle to switch out. But that's why you keep a whole stash of them. Okay, so I thought I was done with this segment, but I figured I'd add this because I spent the last couple of days doing some assembly work. This is how this neat little thing looks when all the pieces are put together. I think this is going to be really cool. I've got an idea how I want to do this when I build it for real. But this has been a good test run. And this is one thing that's neat about 3D printing, what is effectively a kit, is that it gives you a chance to sort of practice and see how it goes together, see what's going to break when you pull the supports off, like I busted the butterfly off the hand. It gives you a chance to look it over, decide how you're going to paint it. It's basically a nice dry run. And you can talk shit about whether or not the designer knows anything about tolerancing, because like in this case, all of the limbs have a square peg and hole assembly arrangement, which looks great. But I kind of feel like they did it with zero clearance, because none of them fit. And it wasn't like even close. So I ended up just chopping all the pegs off and gluing the limbs on there, which was a real hassle. But what I may do is, before I print it for real, I may go into Mesh Mixer or Fusion 360 is making it easier and easier to bring things like OBJ and STL files in and make modifications. Kind of competing with Mesh Mixer, which would be great because I'm not a fan of Mesh Mixer at this point. Anyway, just modifying those assembly features so that this thing will go together easier when I print it for real. Now, in this case, the designer I was talking shit about would be me. This Morrigan thing has been a little bit of a wrestling match. What I really kind of wanted to do was I wanted to be able to sort of paint this thing in parts and then put it together, because a lot of the color separations go along the lines of the physical separations, which was by design. Like right here, this thing is light gray, this part here is dark gray, you know, just places like that. But I'm not really sure how that's going to work out, because I've got it spot glued together with a little bit of super glue, just because I'm, you know, struggling a little bit with those tolerances. And so I decided to just go ahead and glue a bunch of it up and kind of see. It's pretty cool. It's a pretty impressively sized model, you know, even at 144th scale. But this is a really good illustration of how, you know, unpredictable 3D printing can be. I designed this entire assembly with a 0.1 millimeter, so 4 thousandths of an inch, 4 mils clearance on all sides of mating parts. So like, for example, where this scoop fits into its slot, 4 thousandths of an inch on all sides of every mating surface. And I, you know, I felt like that was pretty reasonable, and in some places it worked great. Like these scoops, they pop right in, really nice fit. And you also have to keep in mind when if you're ever in a position where you're designing features that are going to be assembled from 3D printed parts, kind of the rule of thumb is inside dimensions are small, outside dimensions are large. And you would never want to probably go any tighter than 0.1 millimeters. So I was pushing it a little bit, but the bigger issue is on these larger parts where everything depends on all the mating surfaces being planar and parallel and square and you know, so forth. And they're just not. Like, for example, the core of this rear hull is not, all the sides of it were not perfectly straight. And so it does not go onto the front hull perfectly straight. That leaves you with some issues. Places like this, where obviously I want there not to be a gap there, well, again, that's where tolerance stack up comes into play. Because everything's a little bit crooked, these blue parts are not going on all the way right here where they need to be, and so I don't have as tight a fit right there as I would want. You know, so I'm going to have to make some adjustments. And that's why being able to do a dry run is good. And I'm going to pop this whole thing back apart and work on all this stuff before I commit to paint. And I may end up putting it all together and painting it as one big chunk. But at any rate, not all the edges are straight, not all the planes are planar. And so the issue is I could go back and I could make some adjustments in the CAD model. Like, for example, I have more slop right here. This should be a tighter gap right in there where this piece meets this piece. I don't want that angled kind of gap right there like that. I could figure out where the problems are. I could go back into the CAD model. I could make some modifications, and we could cut a new set of STL files and print again. But here's the problem. There's no guarantee that the person who prints the STLs for the master patterns that all the resin castings are going to come from is going to use the same resin, use the same machine, and orient the parts in the same way as all of these parts were done. You've got to have complete continuity through the process if you're going to make changes to the STL or to the CAD database that then translates through to the ultimate printed parts. So I can't really use this thing as much as I, can kind of use it as a dry run. I can't really use it as a diagnosis tool for any changes that I might need to make in the engineering. That's just the reality of it. It's just something to keep in mind if you ever get yourself into a position of designing kits. But one way or the other, this is where all the shit that I've talked about tolerances and engineering over the years is going to come back to haunt me. Okay, so there you go. A little more 3D printing adventure. What I'm going to do with the next episode is switch over to a different resin, which is going to be the Craftsman resin from Anycubic. Lots of people feel like it's got really good resolution and surface finish. So tune in next time. We'll see how that goes. As always, I appreciate you watching. Much love.